next speaker will be Johanna Schmidt. She is the head of the research unit Visual Analytics at the VRVis Research Center in Vienna. And she received a master's degree in computer science. You remember, she's one of the 19% we learned about in the introduction. And she received her Ph.D. in data visualization from the Technical University in Vienna. She's working with visual analysis of large data sets, especially for manufacturing data originating from industry companies and time series data. Please welcome Johanna on the stage, and I'm really looking forward to her talk.
Thank you very much for the nice introduction. Okay, this is the right key, yes. So, some questions that are going to guide us through the talk. The first question is, who are we? So, many thanks for the invitation. That's a nice chance to come to the southern part of Austria again, because we are located in Vienna. We are a research center. We are about 70 employees at the moment. We are located in the 22nd district, very close to the Danube, very nice view onto the Danube. And we are a research center, which means we are not affiliated with any university, so we kind of sit in between universities and industry to make research usable for our industry partners. And our research is concentrating on visual computing, which means that we are interested in all techniques, possibilities, where you need a computer to make data visual. So the main question that drives us is, how can we produce images out of data? And that spans over a lot of different disciplines. So we have people working with 3D data, with simulation data, with very large point clouds, for example. We have people working with medical data, people working with also simulation ensemble data, that's how it's called. And in my case, particular, we are working mostly with time series data. So in my group, my group is called Visual Analytics. We deal with time-dependent data and also high-dimensional data. So the typical data you get if you have sensors and if you have IoT data, Industry 4.0 data. And our part is to make this data accessible for our company partners. So this is who we are. And the other question is, why do we care? Why do we do this research in visual computing? Why is that important for us? And for that, I would like to show you this one example here. It's called the Ansem's Quartet. It was developed by a mathematician, Mr. Ansem. I'm still not sure if I'm spelling that name right, but I hope so. And he wanted to emphasize why making data visual is so important. And then he created this data set. This data set consists of 4 parts. So you see the 4 parts, and every part has an X component and a Y component. And if you do a statistical analysis, then the interesting thing is that all the 4 parts have identical statistical parameters, really identical until the very last place behind the comma. So the mean is the same for X and Y. If you would draw a regression line, it's completely the same. And the variance is the same. So from a statistical point of view, I would say these data sets are the same. But if you plot them, then they actually look completely different. And suddenly, I mean, we could argue that probably the first one and the third one are kind of similar, but we can clearly see that the 4th one is completely out of scope here, and there's just one outlier that causes the statistical values to be similar. And with this data set, Mr. Ansem wanted to emphasize it's so important to also look into the data, because that's something where we as humans are quite good at, We are good in interpreting visual information, so let's do that. And here's another very nice example that was developed afterwards. Again, for all the data sets, the statistical values are completely identical. But even though in one of them a dinosaur is stored in a way. But that's something you only see if you really plot the data. And there's one quote I would like to show here. It was made by Ben Schneiderman. Ben Schneiderman is a professor in the US. He was one of the drivers of data visualization research. And he said that it should be illegal, unprofessional, and unethical to do data analysis using only statistical and algorithmic processes. So quite a strong quote, but really to emphasize that if we want to understand the data, we have to look at it. And there were some other works where visual computing was identified as one of the key enabling technologies in Industry 4.0, because without having any visuals, without having the possibility to look into the data, it's not possible to understand this amount of data that is collected in the production industry. And I would like to show some use cases that we were dealing with together with our company partners. And in the previous talk, we already heard that the quality of the data is actually more important than having a lot of data available. So one of the tools that we developed was to enable our company partners to very quickly find out what is the quality of the data that I have at hand. So are there missing values, are there outliers, and so on. And we developed some visual representations where they could very quickly see how many missing values do we have and how many outliers do we have. So here, for example, we have a data set that records some temperature measurements, and the blue bars show the outliers, and it can be nicely seen that over the whole period of one day, during noon, the measurements are kind of, or the sensors have problems recording the temperature because there are a lot of outliers recorded at that time and all over the week. Or similar example about missing data. So we had a data set containing several time series data, also recorded from sensors. And then there were some missing values in there. And when plotting them above each other, it was possible to very quickly see that actually the times where data was missing was the same for all the sensors. So something happened here probably. The recording didn't work out, or there was a shortage on electricity or something like that. And it's something you very quickly see if you really look at the data. And it might take a little bit longer to do it automatically, but by looking at it, the company partners could very quickly see, okay, what's going on here basically, what's the state of the data. And another example was evaluation of data, because whenever it comes to modeling, whenever it comes to machine learning, we also heard that before, we need on the one hand, we need enough data, we need data of good quality, but we also need to understand the semantics kind of, which means that the data needs to cover a lot of phenomena that we would like to predict afterwards. And there's this one nice example here. These are again time series data recorded over 2 years. And by just looking at it, I think for all of you it's quite easy to see the year change in the data, because there is this drastic change from one year to the other. So suddenly the sensors recorded a totally different kind of data. And our company partners asked us, why can't we use this data for modeling? Whenever we use the data, the model is awfully bad and it cannot predict anything. Why is that? But by looking at the data, suddenly it was totally clear to them, okay, we have two different phenomena here recorded in the data, and this cannot simply be used for prediction. And then they found out that actually something changed here from one year to the other, so they changed how the data was recorded and so on. And of course, then you first need to clean it, and then you can use it for modeling. So we are also very active in this kind of first stage before it comes to applying machine learning. So we are really helping our customers to better understand the data at hand and to find out whether this data can be really used for any type of prediction or machine modeling and similar. And another use case that is kind of still work in progress, I would say, is that our company partners would like to find out, or they would like to, because they're recording a lot of process data and a lot of different processes, and at some point they asked, is it possible to identify kind of the ideal production run in a way? So you have to imagine something like that. So these are pressure curves recorded by the RHI Magnesita. The RHI Magnesita is a big company in Austria, producing stones, and every curve that you see is one production run. And the pressure is recorded that was needed on a certain machine, or that had to apply on a certain machine to the work piece that was produced. And the pressure is kind of different. So sometimes the highest pressure is reached very quickly. Sometimes it takes a little bit longer. There's a strange outlier to the right, as you can see it. And they said, okay, now we recorded all those data. There are several hundred curves in here, recorded over several years. Is it possible to identify like the ideal production process? And we started to cluster the curves to create different groups. So it seems that there are 3 different ways on how those machines are operated. That's something they confirmed. They said, yes, that makes sense because we are producing different materials. And we also started to calculate like the mean curve out of all the curves that we have. And this is the yellow curve that you would see here. But they're still not 100% sure whether this is the right way to do it. So this is really ongoing research, so I cannot present any final result here. This is really what we, in cooperation with our companies, do on a daily basis, that we're really communicating a lot with them. What do you need? Do you think that this is the right way? Nah, probably not. We should do it otherwise. And together with them, I think at some point we will come up with this golden batch, as they call it, the ideal production process generated from the data. And as a last question, what did we learn with all the projects that we had? In general, data visualization is perceived to be something that is important. And so people are sometimes a little bit suspicious if you present them a visual representation that they are not used to. But in general, there's a positive attitude against it, towards it. But to really make it, to increase the acceptance of new tools, it's absolutely necessary to integrate it into the existing workflows. So if you just have one standalone tool where it's complicated to feed in data and so on, it's not going to be accepted by the end users. And this is a very interesting problem. In recent months, I wouldn't say years, but probably months, our data visualization projects are more and more converging towards data engineering projects. So we had some projects that started out like, we need to analyze our data and we need to have a data visualization for that. And we said, great, we know how to do that, let's start. And then you start the project, and then you approach the company partner and ask, okay, where's the data? Yeah, this is stored somewhere here, but we also need this part from the other database, and there are some documents that should be integrated. And then you start out having a data engineering project until you finally can come up with a data visualization. So we have the feeling that more and more data-driven projects in companies are lacking this data engineering step at first place, and it's difficult to have the data at hand whenever starting a project. So it's currently, I think we have more a data problem than an analytics problem. That's at least the feeling. And I don't know if this is different in other countries. We mostly have company partners in Austria. I don't know if other countries are doing better, but here it's definitely something we see in our daily work. We reflected on that in a paper that we published recently in a journal. So if you're interested, there are some more ideas and reflections in there on what we learned during our company projects. And where do we aim at? So we are a research center. We always have to have a vision, of course. And one main part is that we have the feeling that we need to better support companies in their data engineering, data wrangling, and data handling part. And for the visualization side, I think we still need to better understand how do people actually read visualizations, and also to provide new guidance techniques to lower this barrier of approaching a new data visualization that is not known to people. So a lot of things still to do, which is good for a research center, so we'll not get bored in the future. And with that, I thank you very much for your attention.
Thanks a lot for your talk. Johanna, you showed us a lot of graphs. May I ask which techniques you use, or which software, which packages?
Yes, so we have for the time series data, we have a C++ implementation that is based on C++ and OpenGL to provide efficient rendering. And that works quite well if you have a large data set. That is fine. But we more and more see that companies need cloud-based and web-based techniques. So we are also using web-based techniques where we have other problems like how to handle the data flow and so on. But we try to have a quite broad range of techniques and tools available.
Great. Thanks again for your talk. We will see each other in 20 minutes for the Q&A. And please, again, a round of applause for Johanna.
Thank you.